But the reason I tell folks you probably need to look at this kind of thing in particular is you can get a sense on where the field is, what they're doing, and what kinds of actual things are going on in terms of research that are most common, most prominent, and are likely what the field is focusing on as the most important things to look at. Unless you've been under a rock the last couple of weeks, you probably are well aware of Hurricane Helene and the devastation in North Carolina and along the northern Florida coast, as well as in Georgia and a few other places from the resulting flooding and storm surge that did a tremendous amount of damage. And I always hesitate to talk about such things myself because there's enough pundits and people and everything talking about hurricanes and the like going on when they're happening. And for those of you who know, my background is in meteorology and do a lot of work in climate at the moment. So it's always interesting for me to watch because I do enjoy seeing the beauty and pristine of a hurricane, but I also know very much of its devastation and things wrought. And at the time of this recording, Hurricane Milton, which re-strengthened earlier today into a Category 5 hurricane again, is barreling towards the state of Florida, and is likely to cause some more problems, if not be potentially catastrophic there as well. So I will open with that and saying, if you are in that area and you are advised to leave or ordered to leave by your local officials, please do so. This is not a situation to mess around with. And for the folks in North Carolina and Florida and Georgia across the Southeast who are recovering from Hurricane Helene, my prayers, my condolences for everyone. This is an example of a great satellite shot from Hurricane Milton that also pairs together measurement of lightning intensity, and that's actually what you can see in all of these flashes. This is from earlier today, I think right around when it re-strengthened actually into a Category 5 hurricane. It's very impressive. The eye right here is actually very, very tight, and all of these little flashes and flickers right here are lightning, actually, that you can see in the storm itself. These hurricanes are tremendous sources of energy, and the like, but as the National Hurricane Center is saying, Milton's back to Category 5 strength. Florida residents should get their families and homes ready and evacuate if told to do so. I echo that sentiment. Please take it seriously. And for those folks, of course, dealing with Hurricane Helene, my prayers, my condolences, and for my audience, if you wish to donate for recovery, I make two recommendations. This is Convoy of Hope, which is a great group that will go in and bring supplies, get supplies to people, get food to people, help folks out. Samaritan's Purse is also on the ground there. These are two orgs that I highly recommend. So with all that said, again, my prayers and condolences for everyone impacted by Hurricane Helene. But also, if you're in the path of Hurricane Milton, please take it seriously and evacuate if you are told to do so. That said, one of the things that's come up in the news a bit that I wanted to discuss briefly, and it's come up again in the context of thinking about hurricanes, and I think with such event, it's come up with the context of hurricanes. We'll just leave it at that. Has been the notion of what's referred to in meteorology as weather modification. Weather modification is not a super, well, how should I put this? Meteorology itself is a bit older. Climate is a bit older. Weather modification is relatively young as a scientific discipline. And the research therein is therefore relatively young as well. So what do I mean by that? Let me go here, because Encyclopedia Britannica, oddly enough, has a pretty dang decent description of what weather modification is. the deliberate or inadvertent alteration of atmospheric conditions by human activity sufficient to modify the weather on local or regional scales. Um, Humans have long sought to purposefully alter such atmospheric phenomena as clouds, rain, snow, hail, lightning, thunderstorms, tornadoes, hurricanes, and cyclones. The modern era of scientific weather modification began in 1946 with work by Vincent Schaefer and Irving Langmuir at the General Electric Research Laboratories in Schenectady, New York. Schaefer discovered that when dry ice, frozen carbon dioxide, pellets were dropped into a cloud composed of water droplets in a deep freeze box, droplets were rapidly replaced by ice crystals, which increased in size and then fell to the bottom of the box. The Schaefer-Langmuir experiments in the laboratory and the atmosphere demonstrated that so-called supercooled clouds, namely those composed of water droplets at temperatures below freezing, could be dissipated. When the supercooled clouds were seeded with grains of ice, I have a cat causing mayhem in the background. Apologies. With grains of ice, ice crystals formed and grew large enough to fall out of the clouds. Certain substances other than dry ice can be used to seed clouds. For example, when silver iodide and lead iodide are burned, they create a smoke of tiny particles. These particles produce ice crystals and supercooled clouds below temperatures of about -5 degrees Celsius as supercooled cloud droplets evaporate. The water vapor is then free to deposit onto the silver iodide or lead iodide crystals. Although many other materials can cause ice crystals to form, the above mentioned are the most widely used. For the most part, dry ice is dispersed from airplanes, but silver iodide nuclei may be generated on the ground and carried upward by air currents, introduced from airplanes, or produced by pyrotechnic devices such as rockets or exploding artillery shells. So that is just a basic definition of what weather modification actually is. There's a little bit more here, and there's certainly a lot of interesting questions around it. Now, what I just described is the oldest known kind of thing that's referred to as cloud seeding. And it's different because all you're trying to do is to get rain to fall effectively in a particular area, just by providing nuclei, essentially, for water droplets to condense on to the point where they become large enough and fall out as rain. This is all contingent upon there being available moisture in the atmosphere and it being unstable enough that you can actually get clouds. Adding the silver iodide or lead iodide or whatever particle doesn't necessarily do that itself. But cloud seeding, deliberate introduction into clouds of various substances that act as condensation nuclei or ice nuclei in an attempt to induce precipitation. Although the practice has many advocates, including national, state, and provincial government officials, some meteorologists and atmospheric scientists question its effectiveness. First experiments with cloud seeding conducted in 1946. This we already know. That kind of thing there. So, cloud seeding has been around the longest of all these weather modification things. But why, you notice they say local and regional areas. It's only ever really been used and really been effective in a in very local and regional areas. So something like the area of the United States, it's unfeasible. Let's put it that way. It's practically speaking unfeasible. Not to mention there's lots of questions as you don't know exactly what you would do over that large of an area to do that. And so it's still very active areas of research. The other thing I would say falls into the category of weather modification is the notion of geoengineering, which has to do with putting in particular particles. Oftentimes, this is the most common discussed type of geoengineering is the idea of introducing particles into the atmosphere. It's referred to particularly with respect to climate and climate change, but introducing little particles into the atmosphere that can reflect more sunlight back to space and therefore reduce the amount that makes it to Earth and hopefully then cool things down because ultimately a lot of weather and temperatures on Earth comes back to how much solar radiation makes it to the ground. So that is sort of a key thing there. Lots of ethical things around geoengineering because of the amount of particles you're putting up into the atmosphere and, well, who controls the thermostat. Lots of geopolitical ramifications and things like that there. I think I've gotten into that into another video, so I'm not going to dwell on that here. But all of this is to say, you're noticing a theme here, if you're talking about this with me, is that nearly everything to do with weather modification has had something to do with putting some kind of particle into the atmosphere to cause it to rain, essentially, or some kind of particle to reflect things. Aerosols are known to be reflective of radiation. That's why the idea has come up with solar geoengineering in particular. But the most common weather modification thing that's known is what is called cloud seeding, as it were, with that. Excuse me one moment. And that has remained the focus. Now, if you think about it, 1946 being the earliest of such experiments to demonstrate any possibility is really young in terms of science disciplines. There's a huge amount of research that's going on, also with a tremendous amount of ethical questions. Again, the really serious stuff with this began in 1946. So you're talking about a discipline that is not even 80 years old, which is very young as scientific disciplines go. The field of climate science, for instance, actually can trace its roots back. If you read Spencer Weirt's The Discovery of Global Warming, Spencer Weir is a science historian. The foundationals of climate science take it back to the 1850s, if not earlier. So that is just a point to make on that. Of course, meteorology. Physics is, of course, one of the oldest of the scientific disciplines that you can find, along with chemistry. Chemistry is an old discipline, too, compared to this, which is, by comparison, weather modification is very young in here. And so a lot of the focus has been on the introduction of particles specifically. Notice I'm not saying radiation, but particles specifically to, in most cases, produce or induce rainfall in particular areas. And so one of the ways, I wanted to use this as an opportunity because one of the ways you can gauge things going on in the literature around a particular topic is to have a look at major conference proceedings and things like that, where you might have conferences on a particular topic going on. And one such conference that is held every year is the American Meteorological Society, which hosts in its main meeting a conference on planned and inadvertent weather modification. This is from last year. This is from earlier this year. The meeting happens in January of every year. But papers for this conference are solicited on ice nucleation and glaciogenic cloud seeding, studies using cloud seeding agents other than silver iodide, laboratory studies of aerosols, such as ice nucleating particles and giant cloud condensation nuclei that act as seeding agents, modification of mixed phase clouds, modification of warm phase clouds. All that is basically essentially doing cloud seeding on those types of clouds and what happens. New instrumentation or technological advances related to weather modification. This is where you get into some of the new stuff. Recent field campaign results on planned or inadvertent weather modification, societal and economic impacts of planned and inadvertent weather modification. This gets into ethics because there's a heck of a lot of ethical quandaries around this that you got to sort out. So there is that. And techniques for evaluating weather modification studies. This is a publicly available thing. Again, this link will be in the description for you, but this is publicly available. So this is the program from last year. You can get in here and look at this. So yeah, climate and weather modification posters. Let's see. There's a lot of good stuff in here. But the reason I tell folks you probably need to look at this kind of thing in particular is you can get a sense on where the field is, what they're doing, and what kinds of actual things are going on in terms of research that are most common, most prominent, and are likely what the field is focusing on as the most important things to look at in here. So, let's see, new approaches or advanced. So yeah, all of these are recorded. I'm not going to play this right now. Advanced physics, yeah, AI models, glaciogenic cloud seeding, unmanned aircraft for cloud seeding, rain enhancement operation maneuvers with unmanned aerial things, so with drones, doing cloud seeding with drones, as it were. So there's lots of good stuff. I encourage you to go flipping through this. I will say that when I actually looked at this, one of the things I did is the program does have a search option, so you can do this too. I made a point to search for different kinds of things that I heard about online, and there were very, very few in this conference or in the others that were related to some of the things that have come up in the course of news articles and things like that, and the coverage here. And I'm not dwelling on those because for me, there's a lot more junk out there than that is warranted to discuss. So it's one of the reasons I'm not getting into it in depth. But you're going to notice very quickly when you look at this that it's not about infrared radiation being added. It's not about beams from radar or anything like that. Or, and I heard some weird rumor about space lasers. None of that is a topic of any sort of research in here. And there's actually some very good reason that there's been a lot of focus on seeding with particles to produce precipitation rather than to try and use energy itself or to beam thing, or whatever it is at this point, to do manipulation of the atmosphere. And I want to bring it back to this image, not this one, of Hurricane Milton here. And the reason I wanted to show this is because the reason that it's not feasible necessarily to get into doing a whole lot of things with radiation or with energy as opposed to using particles and manipulating material, through providing some condensation nuclei or things like that, is quite simply because of the energy side of things. At least as far as I can find, the energy side of things is the problem. If you take a hurricane just as an example by itself, because it is a small and regional area where most weather modification has been done in the past and continues to be the focus, small by the scale of other things. Let's put it this way. Small by the scale of other things, because a hurricane is relatively small compared to jet stream, compared to weather fronts, compared to a lot of the driving systems. So a lot of things that move a hurricane along actually come from the jet stream, not from anything really unnatural, but or anything like that. So here's the thing with that. There's tremendous amount of energy just in a hurricane in terms of what it can produce. This here comes from Energy Media, and this comes specifically from NOAA, the National Oceanic Atmospheric Administration, written by the National Hurricane Center, originally published by the National Hurricane Center. And what it details is the amount of energy that's involved in a hurricane. In particular, just in a typical hurricane, let alone something like Hurricane Milton or Hurricane Helene or anything like that. Let's just leave those two aside. But in a typical hurricane, one can look at the energetics of a hurricane in two ways. The total amount of energy released by the condensation of water droplets, which is referred to as latent heat, and the amount of kinetic energy generated to maintain swirling winds of a hurricane. It turns out the vast majority of heat released in the condensation process used to cause rising motions in thunderstorms, and only a small portion drives the storm's horizontal winds. Method number 1, the total energy released through cloud and rain formation. An average hurricane produces 1.5 centimeters per day of rain inside a circle of radius 665 kilometers or 360 nautical miles. More rain falls in the inner portion of the hurricane around the eye wall, less around the outer rain bands. Converting this to a volume of rain gives us 2.1 times 10 to the 16th cubic centimeters per day, which, just put it in layman's terms, is a crap ton of rain. A cubic centimeter of rain weighs 1 gram. Using the latent heat of condensation, this amount of rain produced gives us 5.2 times 10 to the 19th joules per day, or 6 times 10 to the 14th watts. Now, to put it in a way that's easier to understand, that's equivalent to 200 times the worldwide electrical generating capacity, which is an incredible amount of energy. And that's just through the cloud and rain formation, the energy that's involved to do the transition between states and produce clouds and rain. The total kinetic energy, the wind energy generated, for a mature hurricane, the amount of kinetic energy generated is equal to that being dissipated due to friction. The dissipation rate per unit area is air density times the drag coefficient times the wind speed cubed. Oh, I'm sorry. Air density times the drag coefficient times the wind speed cubed. One could either integrate a typical wind profile over a range of radii from the hurricane's center to the outer radius encompassing the storm, or assume an average wind speed for the inner core of a hurricane. Doing the latter and using 40 meters per second or 90 miles per hour, which is not a major hurricane, winds on a scale of radius 60 kilometers, one gets wind dissipation rate, wind generation rate of 1.3 times 10 to the 17th joules per day, or 1.5 times 10 to the 12th watts. This is equivalent to about half the worldwide electrical generating capacity, also an amazing amount of energy being produced. Either method is an enormous amount of energy being generated by hurricanes. However, one can see that the amount of energy released in a hurricane created by clouds and rain, by creating clouds and rain, that actually goes into maintaining the spiraling winds is a huge ratio of 400 to 1, which is to say there's 400 times more energy in the clouds and rain portion of it than there is in the wind portion of it. But all of this is to say is you'd need many nuclear bombs worth, many nuclear bombs worth over quite a sustained period of time to match the same kind of amount of energy that's in a hurricane, let alone any other kind of systems of the atmosphere to do that kind of manipulation with energy. That's why there's often a tendency to focus with the research side of things on cloud seeding and the use of particles rather than the use of any kind of energy related things. The question has come up many times in the past of, can you nuke a hurricane? I think actually Trump asked that question at one point. And the long story short is it's just not feasible because the amount of energy that's involved in a hurricane, which is a relatively small area compared to other kinds of systems, is a tremendous amount. And so it just becomes remarkably unfeasible to do. But cloud seeding itself is not known for changing, you can't really change the direction and position of a storm. That's not come up in anything with weather modification that I know of. So there is that, but that's just what I wanted to end on, just to discuss that, to bring it up, because it's become relevant. But I do want to close again. If you're in the path of Hurricane Milton, please take precautions appropriately. Because it is a powerhouse storm, a lot of energy, a lot of wind, a lot of rain, and potential to be very, very bad. So please take precautions accordingly. Let me know what you think. Hit the like button on the way out the door, comment on the video, share the video, subscribe to the channel, all that lovely good jazz. Until next time, I'm Adrienne. May you stay curious.